Hello everyone, here we are for the chapter 8 part 4. So we're going to learn about categories of electrons. So what are these categories? So there is a category that is called inner or co-electrons. So they are the electrons that an atom has, and it is going to be common with the previous noble gas configuration and any completed transition series. Remember, when we were trying to write the condensed electron configuration, we can write noble gas configuration for the previous element, and then you can write the outer electrons. So the co-electrons meaning anything that would resemble noble gas configuration. And also if you have any completed transition series. So what are the transition elements? They are going to be d electrons and also f electrons. And for example, if you have d completely filled up to d10, we consider that also as co-electrons. And similarly, if the f series is completely filled, meaning if it has 14 f electrons, then we consider that also as co-electrons. Okay, and then we have outer electrons. They are the ones in the highest energy level, meaning the highest n value. That's the highest principal quantum number, and those are the outer electrons. And then we have another category that is called valence electrons, and they are the ones that involve in forming compounds. For main group elements, remember the main group elements. Main group elements are the ones that would consider S and P block elements. Excuse me. And they are considered main group elements. The valence electrons are the outer electrons. If you have any S and P, they are going to be the valence electrons for main group elements. And for the transition elements are again d electrons and f electrons. The valence electrons include the outer electrons and any n-1 d electrons. Remember what is this n-1 d electrons means? N is the principal quantum number. If you have the principal quantum number as 4, so then the n-1 is going to be 3d. Always the d electrons start filling up 1 less than the main group elements. Okay, so those are the categories of electrons. We have co-electrons, outer electrons, valence electrons. Excuse me. Okay, so then let's look at this problem and see how we can determine the electron configuration and figure out co-electrons, inner electrons, and what are the valence electrons for these elements. Now we have potassium, technetium, and lead. Using only the periodic table and assume a regular filling pattern, give the full and condensed electron configurations, partial orbital diagram showing valence electrons only and number of inner electrons for the following elements. So you are supposed to write down full and condensed electron configurations. Now let's look at potassium. Potassium atomic number is 19. First we'll go ahead and write down the full and condensed electron configurations. So we can use this order. Aid to memorizing sublevel filling order. So you can use this diagram, right? Remember potassium is 19. So let's see how we can accomplish this one. Okay, potassium, which is 19. Okay, so we're gonna fill up to 19 electrons using this diagram in the right hand side. So first orbital that's going to fill up is the s orbital, which is 1s, and s can hold up to 2 electrons, so then you will write 1s2. Remember, we are going to fill it up until 19 electrons are being filled up. So after 1s comes 2s. So you just follow the order 2s2. What comes after 2s2? It's the 2p. So you're going to go back. So once you are done with the 2s, you're going to go back and then you start with 2p. Okay, so after 2s comes 2p. So now for the p, there are three possible orbitals. Each one can hold maximum 2 electrons. So the p orbitals can hold up to 6 electrons. So we're going to fill up all the way to 6 electrons, right? 2p6. So after 2p is done, then it should go to 3s. So then goes to 3s. S can hold up to 2, so you're going to write 3s2. So after 3s2, what comes after 3s? You're going to go back and then you start again 3p. After 3s, it's a 3p. So again, p can hold up to 6 electrons. Now for potassium 19, we have already filled up 2 plus 2, 4 plus 6, 10, and then with 2, 12. How many more do we need? We need 7 more, right? So 3p can hold up to 6 electrons. So we need to fill up all the way to 6. Now we have 18 electrons. So what comes after 3p? It's the 4s. You see, after 3p, arrow goes to 4s. So we need one more electron. So you're going to write 4s1. And that is going to be the full electron configuration for potassium. Now, if you want to write down the condensed electron configuration is that you write the noble gas prior to potassium. What's the noble gas prior to potassium? It's going to be argon, right? Argon is 18. So you write argon and then you put a square bracket. It's up to 18, which is up to 3p6, that's 18. And then what's left is 4s1. So this is going to be your condensed electron configuration for potassium. Okay, argon 4s1. And then what else we need to do for this one? We need to find out the condensed electron configuration, partial orbital diagram showing valence electrons only, and number of inner electrons for the following elements. Now, what are the valence electrons for this one? Now, what are the valence electrons? Now, this is a main group element because it's in the S block. So, your valence electrons for this one is going to be this 4s1. 4s1 going to be your valence electrons. And how many valence electrons are there? Only one valence electron. So this is your valence electrons. Okay, and then you also need to find out the co-electrons. Co-electrons are the ones that is resembling the noble gas configuration, which is argon, so which is 18. So the co-electrons are going to be, number of co-electrons for argon is going to be 18, and the valence electrons are going to be 1 electron, which is your 4s1. Okay, so here's the solution. This is the electron configuration that we all did together. Condensed electron configuration argon 4s1, and then the partial orbital diagram showing valence electrons. Only 4s has 1 electron. After 4s we have 3d and 4p, but we don't have anything in 3d and 4p. Inner electrons in potassium are those in the argon part of the condensed electron configuration. So there are 18 inner electrons. Okay, and similarly the next one excuse me, is going to be technetium. Technetium atomic number 43. So now we need to find out and fill up to 43. Okay, so again we're going to follow the same procedure over here like we did. So we had to go up to 43 following the same order. Okay, so try to do it yourself by looking at the diagram. So technetium, it would be configuration. So you will first do the 1s2 and then the 2s2, 2p6, 3s2 and then goes to the 3p6. Follow the order in the previous slide, and then goes to the 4s2, and if you follow the order, after 4s2 comes 3d10, and then after 3d10 we have 4p6, 5s2, 4d5. Okay, so that is 43. Let me see if I can do it with you. Let's insert a new slide. Sorry. Copy. Okay, so let's use this one, this diagram. I'm going to keep it over here, and we'll see if we can, excuse me, write technetium 43 by looking at this diagram. I'm just doing this with you guys for you to practice. Okay. Okay, so technetium is 43. So we're going to do it now together. So we have technetium 43. Let's see. What is the first thing that we're going to write? We're going to write the complete electron configuration. So we have 1s2. Okay. And then comes the 2s. 2s can hold up to 2 electrons. So we have 2s2. And then after 2s2 goes to 2p. P can hold up to 6. So you go to 2p6. After p comes 3s. So you go to 3s2. Okay, so after 3s2, then you go to 3p. So p can hold up to 6, so 3p6. After 3p6 goes to 4s, 4s2. So after 4s2 is done, you're going to go back again here and start from there. That's going to be 3d. Remember, d can hold up to 10 electrons, so you're going to fill up all the way to 10 because we have not come to 43 yet. So after 3d comes 4p. 4p. Let's see how many we have done so far. So up to here it is 10, 2 plus 2, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18 plus 2, 20, and then 20 plus 10, 30. So we have included 30, so we need more. So now with this 6, that will make it 36. So 4p6 would be 36, and then 5s2, 38. After that comes 4d. 4d. So 38. So how many more we need to 43? We need 5 more. So 4d will fill up to 5. That will make it 43. Isn't it? I hope I did my counting correct, but let's go back and see. Go back. Yes, 45. You see, we fill it up to 45, and that's going to be 43 electrons, and that is going to be your complete electron configuration. Okay. Now, what is the noble gas prior to technetium? So the noble gas prior to technetium is krypton. Okay. So krypton up to here. So up to here from the beginning, that is a krypton electron configuration 4p6. So the condensed electron configuration would be krypton, and then you have, sorry, it has to be the other way. Krypton. Let me write it again. Technetium, it would be krypton, noble gas prior to technetium, and then what it's going to be up to here, and then what's left is 5s2, 4d, 5. That's the condensed electron configuration. Now in this case we have this many up to krypton number co-electrons. Okay, and that is going to be 36. So there are 36. So krypton is 36. So there are 36 co-electrons. And then what are the valence electrons? So in this case, the valence electrons are going to be this 5s2 and 4d5. Trying to find a different color. So these ones, they are going to be your valence electrons. Because the D is not completely filled. When the D is not completely filled, they are considered valence electrons. So the highest energy level, which is the 5s, and also in any incomplete D electrons are considered valence electrons. So there are 7 valence electrons for technetium. Okay. So 5s2 and 4d5 going to be your valence electrons. So this is the solution for the technetium. Condensed electron configuration is given in the partial orbital diagram. So you can see 5s2, 4d5. And remember, S can hold up to 2, and then there are 5d electrons, and we singly occupy them, having 1 electron each before we pairing them up. Okay, so 5d5. So the inner electrons in technetium are those in the krypton part of the condensed electron configurations. So there are 36 inner electrons. Okay, and then we're gonna do lead 82, and that's a good one for you guys to practice. Okay, just like we did for the krypton, potassium and technetium, go ahead and do it for the lead, and then you can also follow this diagram how to find out up to 82. So I want you guys to practice that one yourself. And also the answer is given here. Write it down and see if you guys can also get the same configuration. It's a long one, okay, but it's worth writing it down. And then, so this is the one, the complete electron configuration. The condensed configuration would be noble gas prior to xenon, and then you're going to write what is left. What is left is after xenon, 6s2, 4f14, 5d10, and 6p2. That's the condensed electron configuration. And in this one, you can see that D and F are completely filled, meaning D can hold maximum up to 10, F can hold maximum up to 14. Since the D and F are completely filled, they are not going to be considered as valence electrons. So in the partial orbital diagram, if you show the valence electrons, they are going to be highest energy levels, which is going to be your 6s2 and 6p2. So s2, p2. So there are only 4 valence electrons because F and D are completely filled. The inner electrons in lead are the 54 electrons represented by xenon plus the 14 in the filled 4f level and then the 10 in the filled 5d levels. So if you look at the co-electrons, you have to count the number of electrons up to xenon, and then the 14 from the F and 10 from the D, they all considered as inner electrons or the co-electrons. Okay, so there are 78 inner electrons, and then it has only 4 valence electrons. Okay, so I will conclude this section from here, and then we can go ahead and start the atomic size in a separate section. Okay, then bye for now.